Here's a little bit on the A+ tiles. When students come to your station, you want them to be able to understand that patterns are everywhere, and part of their goal is to look for patterns in all kinds of stuff and whatever they see. The hundreds board is no different. It's chock full of patterns. There's all kinds of stuff that you can see. If you feel like you want to spend a minute going through and saying, oh, well, we have, patterns, going down where you get 1, 11, 21, 31, and they all end in 1, that's great. I don't think the MathMasters 2, the 5th graders need to do that because they've done that all before. So what you want to do is you want to be able to walk them through the first activity, which is odd and even. And the goal is for them to see the pattern and see how to get those patterns to emerge without you telling them, look here, look there, look for this. You want them to be able to find those patterns themselves. When the activity starts, the B tile is brought up like this, and it's in its home position right now. So that's tile, it's covering 1 and 2. And so you might ask the students, what do you know about those numbers? And let them discuss it. They don't have to tell you directly, but they can kind of discuss it with their partner for 20, 30 seconds. Just let them discuss. It doesn't have to be a teacher-student combination of dialogue. It can be student to student. So give them just a second. Hey, talk to your partner. What do you guys see? All right? Go ahead and jot a few of those down on a piece of paper and see what you come up with. All right? So what do you know? Then they may say things like 1 is odd, 1 is even, they're 1 away from each other, the sum is 3, they're right next to each other, all kinds of stuff. And then go, okay, those are great. I heard some good things as I went around the room and listened to you guys talk to each other. All right, let's move it over here. Now what do you see? Which stayed the same, which changed? Do you need to adjust any? Did anything stay the same for this one and this one? And give them a minute to do this. And then go, okay, one more time. Move it over here. Are there any patterns showing up? Which ones did you have to adjust? Which ones do you need to eliminate completely? Which ones work? And now the question is, do they work all the time? And this is a time where you get kids to move it around the board and see if their conjectures work. So don't ask them if they work and tell them if they're right. Have them move the piece around the board and see if it works. And as soon as they get, oh yeah, it does work, or no, it doesn't work, go, okay, well, can you find one that does work? Some of the things that do work are, it's always odd, there's always an odd and always an even, and the sum is always odd. The two numbers are always next to each other. Other ways of saying those basic pieces of information are great. Some kids may say, one's prime, one's composite. That doesn't work for 1 and 2 because one's neither prime nor composite. And then if you put on 2 and 3, those are both prime. You move to 3 and 4, one's prime, one's composite. 4 and 5, one's prime, one's composite. And then, but when you get to 8 and 9 and 10, oops, it changes. So be prepared, just to say, make sure it works all the time. And if you're not sure, have them do it. Don't feel like you have to know the answer, right or wrong, yes or no. They can say, you can say, check it, and they can go, oh, okay, that does work, or that doesn't work. The idea is for them to make the conjecture, and then for them to test their conjecture to see if it works. It's more of a scientific process than it is do these mathematical steps and come up with an answer. That's what we're trying to get at with the A+ tiles activities. So once they do that, once they figure it out and you've gone through and helped them with this, go ahead and bring them back and get a couple of those good answers out so the whole class can see, oh, one's odd, one's even. That always happens. They're 1 away from each other. They're consecutive. I would use that term consecutive. What does it mean when two numbers are next to each other? That's consecutive. Get that vocabulary going. And then finally, that the sum is always odd. Now, if anybody says, well, what if I turn the tile? That's important because that is a different orientation. And instead of saying, don't turn the tile, say, well, let's keep it this way for right now. and finish this out, and then we'll turn it and see what happens there. And it turns out, no pun intended, that when you switch the tile to vertical, that on the vertical, when a tile is vertical, the sum is always even, not odd. And so it's good for kids to see that when they come up with that conjecture. Then you can ask them the question, why? You can also ask them the question, why is it always odd when it's the other way? And some great answers I've heard, even my son in 2nd grade say, oh, well, 3 and 4, everybody has a partner except for one, except for the one guy with 4. He doesn't have a partner, so it's odd. And 4 and 5, well, everybody has a partner, but there's one guy left over. There's always one guy left over. And he said that before, and that's great. And so the idea of an odd being literally an odd man left out is a great concept and great number sense for kids to have. So that hopefully will give you a little bit more insight into how to work the hundreds board and that first activity, odd and even. For the civ of Eratosthenes, what you want the kids to do is kind of put a special star on 1 because it's neither prime nor composite, and then start with 2. And 2, they want to circle that because that's prime, and then X out all the multiples of 2 because, of course, they're multiples. That means they're not prime. The next available number is 3. They would circle that, and then cross off all the multiples of 3 that are not already crossed off. Then they go to the next available number, which in this case happens to be 5, and they circle 5 and then cross off all the multiples of 5 that are not already crossed out. So you can see they just keep doing that until they are done. Now the question is, how far do you go? And for the teacher, please do not tell the students this. They need to figure it out. But once the students hit 11, they should be done. They should have all the primes all the way through. Why? Because 11 times 11 is 121. That's bigger than 100. So any other thing, 11 times 3, 11 times 4, smaller numbers have already been covered. And then 11 times 12 or 13 or bigger numbers is way past 100. So you've already covered all you need to cover just by doing up to 11. You don't need any more. And that's an aha you want the kids to find, because it talks about multiplying two things together and what your result is. And when you take a number and you multiply it by a smaller one, you get something smaller than the square of the number. And when you multiply a bigger number by that, you get a number bigger than the square of that number. Okay? So the idea is for kids to explore. After those two, I would kind of try to let the kids do whichever ones they want to do and be able to explain them, explain what they're doing. The goal is for them to look at it, look for patterns, and come back to you and say, oh, I found this, or I found that. We were able to go through here and we found these patterns, or we were able to do this. We were able to build a 4x4 with the tiles. So those are the kind of things you want the kids to do, and there's going to be some exploration. I will tell you, by the time you go through the odd and even together, giving them time to think, giving them time to figure it out, not telling them, and then do the civ of Eratosthenes, you will probably only have about, I don't know, of the 75-minute block, you may have 30, 45 minutes left to do the others. And of that 30 to 45 minutes left, you need at least 10 to 15 minutes for kids to share. And you want the kids to be able to share with each other. And if you can't get everybody to share, have one person share and say, okay, how many people found that out? Great. You guys, 8 of you found that? That's awesome. Okay? Oh, you found one? Nobody else found it? Is it right? Is that really a pattern? Guys, what do you think? And have a moment to do that. Don't just plow through the conclusion and say, okay, great, next. Okay, great, next. Okay, great, next. Have the kids assess some of the conclusion on their own and say, oh, Yeah, that works, that works. You know, if I square the numbers, this happens. I got it too. Okay, great. So we've got some confirmation on that. All right, let's see what else we have, and then move on from there. But don't make the conclusion just boom, 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 we're done, we're out, it's over. Do it a little more with a little more involvement of the students and have them assess the conclusion and see if it's right or wrong. The one thing I caution you on, though, don't let wrong answers hang out there. You have to address them. If nobody gets to them, then go ahead and say, I'm not sure that's quite right. We need to have a confirmation on that. Nobody's got it? All right, let's put this up here. You know, you said that it covers a prime every time, but if I cover 14 and 15, 14 is 2 times 7, 15 is 3 times 5, that doesn't work. So once we've shown that it doesn't work, 15 and 16 doesn't work. 8 and 9 doesn't work. 9 and 10 doesn't work. You may want to give a couple more examples or let other students do it and then be able to say, okay, so it worked for a while, but now it doesn't, so we can't say that's a rule that works all the time. So those are the kind of conversations you want to have with kids and have kids have with other kids, and that's a good way to wrap up this activity. Okay? Have fun, enjoy, and let me know what you think. Bye.